From you live from Mr. G's remote classroom. We have a pretty sad story today. This is lesson 7 of our mini unit, and it is the dramatic animation, please. Our last lesson, gist of the unit. Coming at you next unit, we're going to be talking about fractions. That's right, mathematicians. To end the school year, we'll be working on fractions. I know that we investigated a little bit into it last lesson. We've had fractions a part of our curriculum past couple of grade levels. It isn't going anywhere. So, stay tuned. Casting, probably not my strong suit. You guys be the judge. Other than drawing those tears, what you'll need for today's lesson is, shockingly, a paper, a pencil, and that nifty calculator. Now you're thinking it, I won't say it, but I will use my telepathy to tell you. Let's take one last look at those learning targets that all of us have become so familiar with. The first one, I can find quotients with remainders of division problems with single-digit divisors and dividends to the thousands place. I can determine quotients with remainders using standard form or, of course, partial quotients strategy. I can solve remainders in decimal form to the hundredths place. And lastly, as we visited before, our most recent learning target, I can represent remainders in fraction form, and I understand fractions can be calculated to be decimals. Our last opportunity to practice these learning targets together, and then I'll be tossing you out of the nest for you to flap those wings on your own and show me all those wonderful things that you've learned in the past 7 lessons. All right, guys, jump in straight into that I do. I have my steps down, ready to go. I have my tape measure, ready to go just in case I need it. My expression, my division problem, 6,794 divided by 8. I'm tackling this problem with standard form. Hence, our steps. Step 1, I need to divide. I need to start in that hundreds place. I'm asking myself, can 8 go into 6? 8 times what number will give me 6? Or close to it? The answer is it can't. 6 is smaller than 8. I need to move to that next place value. I need to move to that hundreds place. So I'm now thinking 8 times what number is going to give me 67 or close to it? Working with big numbers, bigger numbers, working with factors or divisors that are a little bit more challenging. Let's jump to the tape measure. I know that 8 times 0 is going to give us 0. I know 8 times 5 is going to give me 40 because I can skip count by 5s and I know my 5s real well. I know that 8 times 10 is going to give me 80 because 8 times 1 is going to give me that 8. 8 times anything times 1, it's going to give me itself. I tack that 0, 80. So, looking for 67 because that is my dividend. That's the number I'm looking to divide. I know that 67 is greater than 40 and less than 80. So, I know it's going to fall between a quotient of 5 and 10. So, I can work backwards, I can work forwards. I know 67 is about in the middle. I'm going to work backwards. I'm going to subtract 8 from 80 to get 72. 8 times 9 is 72. I'm going to subtract another 8 more. I know a group of 8 less. 8 less than 72 is going to give me 64. So, looking at a quotient of 8, I know I'm looking for 67. 8 does not go into 67 evenly. The closest I can get is 64. So, 8 times. I need to multiply. Divided, now I need to multiply. 8 times 8 is 64. I need to subtract. 64 minus 67. Only thing that's changing is my ones place or the hundreds place. It's going to give me a 3. 4 minus 7 is 3. I need to bring down. I need to bring down my tens place. That is going to be that 9. So, I already did my legwork. Okay, I'm now redoing. I'm bringing on around. I need to divide 8 into 39. Luckily on the tape measure, I already did some work. I'm looking for 39. I know 5 groups of 8 is going to give me 40. That is too much. So, what is 1 group less 4 groups of 8 going to give me? It's going to give me 32, because that is 8 less than 40. So, 8 times what numbers? Going to give me 39. I know I can't go in evenly. 8 times 4, though, will give me 32. 8 can go into 39 4 times. I divided. I need to multiply. 8 times 4, going to give me that 32. I need to subtract. 32 minus 39. 2 minus 9 is going to give me 7. 3 minus 3 is going to give me nothing. I need to bring down. I need to bring down my last place value. I need to bring down that ones. Those ones. Okay. Bringing it back around. Redoing. I'm asking myself, 8 times what number is going to give me 74? I'm dividing 8 into 74, using that inverse operations to help me. Well, I know I've already done that great legwork on my tape measure. I know that 8 can go into 72 non-equal times. I know that one more group of 8 is going to give me way too much. That's going to be 80. So, it can go in 9 times. I divide it, I need to multiply. 8 times 9, we know is going to give us 72. I subtract out. 2 minus 4, it's going to give me 2. So, I found my first step to finding a remainder. But, we have those wonderful extra place value. Extra learning targets that involve place value. Excuse me. I could stop here if we were looking for remainders. 849, remainder 2. I also could find that fraction remainder. 849 and 2/8. 2 over 8. But we're learning how to find remainders in decimal form to the hundredths place. So we keep going. I know there's nothing there. I am now working with quotients less than 1. I need to bring down a 0 because I got nothing. Bringing down that 0, need to restart. I'm dividing. How many times can 8 go into 20? 8 times what number? 8 times what number is going to give me 20 or close to it? Well, I know 2 groups of 8 is 16, and I know 3 groups of 8 gives me 24. So 24 is too much, goes in twice, not equally. 2 times 8 is 16. I subtract and get a remainder of what, guys? I know I can't subtract 6 from 0, so I need to steal. 6 minus 10 is 4. I have nothing in my tens place. I subtracted, I need to bring down. I have no place value here, I need to go to my hundredths. Bring down that next 0. And lastly, I bring it on around and I can divide one more time. I know that 8 goes into 40 5 equal times. Our I do quotient, 6,794 divided by 8 is 849 and 25 hundredths. I do standard form. All right, moving on to that I do for partial quotient strategy. My expression, my problem, 8,649 divided by 6. I know I'm chunking and subtracting until I can't, then I'm adding those remainders and those partial quotients at the end. But when we're finding decimal remainders, we know there's that trick to finding those quotients using the strategy we learned last time. I want to fill out my tape measure before I do anything to help me out. I know 6 times 0 is always going to give me nothing. I know 6 times 5 is like skip counting by 5s. I know that's 30. And I know 6 times 10 is going to give me 60. 6 times 1 would give me 6. Tack that 0, 60. So when I'm chunking and subtracting, want to think big, look at numbers I know, chunking and subtracting till I can't. Well, I see right away, I got a 6 looking right at me in the hundreds place. So I know I can chunk that right out right away by chunking that 100. So 6 times 100 would give me 600. 6 times 1 would give me 6. I tack those 2 zeros. 6 times 100, just chunk it out. 600. Oh, guys, I forgot that darn line to separate my work. 600 minus 8,649. I know I'm just taking away that hundreds place. I'm going to get 8,049. So, need to think big, look at numbers I know, work with numbers I know. All right, so I got this 8,000 I'm looking to chunk out. Okay, let's take a look at that bigger tape measure. Looking at that tens and that 100. So I know 6 times 0 is going to give me nothing. I know 6 times 5 is like saying 30. 6 times 5 is 30. Tack that 0 is 300. And I know working with tens, hundreds, thousands, just tacking that 0. 6 times 1 is 6. Tack those 2 zeros, 600. So I'm working even bigger than that. What if I chunk out 1,000? 1,000 is going to give me what, guys? I know 6 times 1 is going to give me 6. But if I wanted to chunk out in my thousands place, I could tack 1, 2, 3 zeros. 1, 2, 3. 6 times 1,000 would give me 6,000. That will give me some serious chunking out of this number. 6 times 1,000 is 6,000. Let's subtract. I know the only thing that's going to change is my thousands place. 6 minus 8 is going to give me 2. I have 4 and a 9 in my tens and ones place. So I still got a lot of number to chunk out. Look looking at my hundreds and my 50, I know I'm not going to have enough number to chunk out there. So, a number that is less than 1,000, but greater than 100. I'm curious to take a look at what the tape measure would look like if I was working with 1,000. Let's take a look. I know that 6 times 1,000 is going to give me 6,000. Okay, tacking those 3 zeros. So I could think of it this way. A half of 1,000, between 0 and 1,000, I know halfway between 0 and 10 is 5. So halfway between 0 and 1,000 is 500. I can use my same rules. 6 times 5 is going to give me 30. I tack 2 zeros, that's going to give me 3,000. So 6 times 500 is going to give me 3,000. That's too much. That is almost a full 1,000 more than 2,000. So I know 2,000 would probably fit around here. Let's see what 200 would give me. I know 6 times 2 would give me 12. I tack 2 zeros. That would give me 1,200. I'm trying to get as close as I can to 2,000. What if I chunked out 300? I know 6 times 3 is 18. I tack 2 zeros. 1,800. I know that's a lot closer to 2,000. Let's chunk that out. Let's chunk out that 300. And now that's going to chunk out 1,800. I subtract out. I know the only thing that's changing is going to be my thousands place. So, but I still, for consistency, want to subtract because I have another place value here I need to be aware of and a 0 there. So 0 minus 9 is going to give me 9. 0 minus 4 is going to give me 4. I cannot subtract 8 from 0. I need to steal 1,000, make it 10 hundreds. 8 subtract 10 is going to give me 2. All right. Some serious math going on here. I have 249 left. Running out of room? That's okay. Let's take another look at how I could chunk out 249. Let's take another look at that smaller tape measure we had. Let's say I'm working on that 100 tape measure. I know 6 times 100 is going to give me 600. Way too much. I know that 6 times 50 is going to give me 300. Just a little bit too much. I know that 249 is going to be around here. So let's try, what would 30 give me? 6 times 3 is 18. Tack that 0. 0. What about 40? You know, 6 times 4 is 24. Tack that 0. 240. Wow, look at that, guys. That's pretty darn close. The only thing missing is my ones place. Let's do that. 6 times 40. It's going to give me 240. I subtract out, and I'm going to have that. I'm going to run out of space. I'm going to have those 9 ones left. This is why we need to work with a blank sheet of paper with lots of room. So I got that 9. I need to chunk that 9 out. I know 6 can go into 9 only once. 1 times 6 is 6. Subtract it out. I have our remainder. So I could stop here, but we know we're working to that hundredths place. Excuse me, that hundredths place. So let's take a look at that place value chart one more time. All right, so once again, we're looking at quotients with remainders falling in the hundredths place. We have a remainder of 3 in our ones, but we need to continue finding a quotient that will get us to that hundredths place. That is 2 place values away from where we are. We need to regroup 2 more place values, so that's going to cause us to need to add 2 more place values. So, could have stopped there with a remainder of 3. We need to keep on going to remind ourselves we're working with decimals. We're going to put our decimal in there. We're going to make a separate partial quotient. We're dividing 6 into 300. Going to put that decimal down so we do not forget. Okay, so look at this, guys. I already had on my tape measure that 6 times 50 would give me 300. That's exactly what we're looking at here. I can chunk that out right away because I did all that hard math work earlier on my tape measure. I know 6 times 50 would chunk this thing completely out. Nothing left. We got all the way to that hundredths place with nothing left over. There is my decimal remainder. 0.50, 50 hundredths. So, next step, I need to add my partial quotients and then add my decimal remainder. Let's do that. Let's do that right here. I'm going to do it in a different color because we're doing so much math work. Always want to add my bigger partial quotients first. I got 1,000. I have 100, 300. I have 100. I have 40. And I have 1. Adding them all together. 0 plus 0 plus 0 plus 0 plus 1 is going to give me 1. Nothing plus 4 is going to give me 4. Nothing plus 3 plus 1 is going to give me 4. 1,000 plus nothing plus no other thousands is going to give me 1,000. 1,441. Can't forget that decimal place value we worked so hard to get. 1,441 and 50 hundredths is our final quotient. In case you couldn't see it, we had so much math work on that board it got really small. Our final quotient when we added our decimal remainder in the hundredths place and our partial quotients together with those holes, our final quotient was 1,441 and 50 hundredths. 1,441 and 50 hundredths. All right, guys, moving quickly into that we do. So we're just going to do one problem for each strategy, practicing together these learning targets for one last time. All right, guys, we do for standard form. Our expression, our problem, finding quotients with remainders to the hundredths place. 9,689 divided by 7. I got my tape ready to go. I know I'm working with advisor, that might be a little tough. I got my steps. Divide, multiply, subtract, bring down, bring it around, or redo, or bring it on back. All right, starting in that hundredths place, as always, because we're using standard form. I'm asking myself, can 7 go into 9, or 7 times what number is going to give me 9 or 9 thousandths? Well, no, it's a bigger number. Can go in once. I know 7 times 1 will give me 7. That's awful close to 9. That's only 2 away from 9. I divided. I need to multiply. We need to multiply. 7 times 1 is going to give us what, guys? 7. Next step, I need to subtract. I need to subtract 7 from 9. I know 7 minus 9 is going to give me, I have 9. I take 5 away to get to 4. I take 2 more away to get to 2. 7 minus 9 is going to give me 2. I subtracted. I need to bring down that hundredths place. My 6 is in that hundredths place. Need to bring it around. Need to divide again. How many times can 7 go into 26? Very briefly, let's take a look at our tape measure. We're starting to work with some dividends that are getting tougher. I know 7 times 0 is going to give me what, guys? What is any number times 0 going to give me? 0. I know 7 times 5. I can skip count by 5s. I know my 5s are always going to end in a 0 or a 5. 7 times 5, 5, 10, 15, 20, 25, 30, 35. And I know working with tens, hundreds, and thousands is easy, so I'm just tacking in that 0. 7 times 1 is 7. Tack that 0, 70. Looking at 26, I know 26 is close to 35, so if I wanted to, if I didn't know, if I didn't have a place value chart, if I didn't know a quotient that was close, I could use the tape measure. 7 less, a group less than 5 is 4. 7 less than 35 would be 28. Still too big. Group of 3, 8 less would be 21. Found that quotient we're looking for? 3. We divided. 7 can go into 26 unevenly. It can go in 3 times. Multiply. We know 7 times 3 will give us 21. We subtract. 1 minus 6 is 5. 2 minus 2 is going to give me nothing. We subtracted. Need to bring down. We need to bring down the next place value. We were in our hundreds. Need to go to our tens. We have a 8 in our tens. Need to bring that thing down. Bring down that 8. Need to bring it on around. Need to redo. Need to divide. But now I've regrouped and I have a dividend of 58. Again, working with a tougher dividend. That's why we got the tape measure. I know that 58 falls somewhere between 35 and 70. I'm going to choose to start with my groups of 5 and work our way to 70. So I know I'm going to be adding groups of 7, not subtracting groups of 7. So if I had a group more of 7, I could add 7 to 35. I know that is 42. Kind of close to 58. I think I can get closer. Another group would give me 7 more than 42. That would be 49. Still think I could get closer. What about 8 groups of 7? One more group of 7 would be like adding 7 to 49. That would be 56. 7 does not go into 58 evenly. The closest we can get is 8 groups of 7. Equal groups. That's what we're working with. I divided. I need to multiply. 7 times 8. 7 times 8 gave us 56. We multiplied. We need to subtract. 56 minus 58. I know the only place value that's changing is our 1s. What is 6 minus 8? That would be 2. Subtracted. I need to bring down. Was in my hundreds. Excuse me, I was in my tens. Now I need to work to my 1s. Need to bring down that 9. Running out of space. All this awesome math that's going on. Look, guys. We did all that work on the tape measure. Use our resources. I know that 7 4 groups of 7 will give me 28. That is only 1 less than 29. All our work has been done for us. 4 times. 7 can go into 29, not equally, but can go in 4 times. 7 times 4 is 28. I subtract out. 28 minus 29 is going to give me 1. We could stop there. We have 1,384 with a remainder of 1. Guys, what would the fraction remainder be in this case? If I have a 1 as my remainder and a 7 as my divisor. Think about it. 1,384, but what would be our fraction remainder? Would it be 7 over 1 or 1 over 7? It would be 1 over 7. 1,384 and 1/7. 1/7. But we know we are working with decimal form to the hundredths place. We need to keep on going. But we ran out of space. I ran out of space. Gonna have to start working over here. I'm gonna write my 1 here. That way I'm staying in the right place value. So I have nothing to bring down. So I know there's a 0 there. I'm working smaller than wholes. I'm working into decimals. Got to put that decimal down for those quotients. I'm going to put my 1 a little bit higher. Okay. Now I need to bring down that 0. Working with 10. How many times is 7 going to 10? Well, I know 2 times 7 would be like saying 7 plus 7. That would be 14. That is too big. Only goes in once. Only goes in once. We brought down that 0. We need to bring it around. We divide 7 into 10. It goes 1 time. Divided, you need to multiply. 1 times 7 is 7. I subtract out. Guys, what is 7 minus 10? 5, 10. Take 7 away. Take 5 away to get the 5. Take another 2 away to get the 3. 3. 7 minus 10 is 3. I need to bring down again a 0. I have nothing there. I need to bring down a 0. Bring it around. Dividing 1 last time. Working in that hundredths place. How many times is 7 going to 30? 7 times what number? It's going to give me 30 or close to it. I did all that awesome work on my tape measure. I know 7 times 5 is 35. Too much. But I do know 7 times 4 is 28. That's as close as we can get. 7 times 4, we divided to get 4 groups of 7. 7 times 4 is 28. I subtract out. I don't need to keep going, guys. I have my quotient with a decimal remainder. 9,689 divided by 7 will give us a quotient to the hundredths place of 1,384 and 14 hundredths. All right, guys, we do for partial quotient strategy. My expression, my problem I'm working with here, being the human calculator we are, 4,593 divided by 9. Because I'm working with partial quotient strategy, I made 3 tape measures. Why not? Might be working to that thousands place, who knows? So, looking at my numbers here, I see a 9. I know I'm working with 9 as my divisor. I see a 9 in my tens place. What does that mean? How can I chunk that 9 in that tens place out? Well, I'm thinking 9 times what number would give me 90? I know 9 times 1 would give me 9. If I tacked a 0, I know I'd have to tack a 0 in my groups. It would go in 10 times, writing way too big. Okay? If I want to chunk that 9 out, that 90 out, 9 times 10 would give me 90. I chunk it out. I forgot to, once again, write my line here. My partial quotient line. Let's subtract 90 from 4,593. No, I'm just working with that tens place, knocking that 9 out. So, going to have a 0 there. All the other place values are going to stay the same. Do I see any other numbers that look friendly to me? I do not, but I do know I need to chunk big numbers. So, if I want to chunk the biggest number, I need to chunk the biggest place value. Let's take a look at this thousands tape measure I got here. Guys, what is 9 times 0 going to give me? 9 times a 0, anything times a 0 is going to give me 0. I know that if I want to find out what 1,000 is going to give me, I know that it's like saying 9 times 1 is 9. Tack 1, 2, 3 zeros is going to give me 9,000. Move this over here for space. Okay, so 9 times 1,000 is going to give me 9,000. I'm only working with 4,000. Way too big. What about if I work to my 500? Well, I know 9 times 5. Maybe I don't know what 9 times 5 is, but I know that 5s are easy. They end in 0 or 5, and I can skip count by them pretty easy. 5, 10, 15, 20, 25, 30, 35, 40, 45. You know, 9 times 5 is going to give me 45. If I tack 2 zeros, made these tape measures too close. If I tack 2 zeros, that would give me 4,500. Look at that. 4,503 is what I'm working with. I could chunk that out. That's a big old chunk. Let's do it. 500. I know 9 times 500 is going to give me 4,500. It's going to chunk both these place values out. 9 times 500 is going to give me 4,500. I subtract. 0 minus 3 is going to give me 3. It's going to give us 3. 0 minus 0 is going to give us 0. 5 minus 5 is 0. 4 minus 4 is 0. Yikes. Some serious chunking. We only have 3 ones left. Can I divide 9 into 3? 9 times what number? 9 times what number is going to give me 3? Well, I know 9 times 1 will give me 9. Well, I don't think there is a number because 3 is smaller than 9. Can't do it. Cannot do it. So I have my remainder. We could stop there if we weren't solving for remainders in decimal form to the hundredths place. So I got to take this remainder. I need to make my remainder expression 9 into 3. Guys, let's take a look one more time at when we're using partial quotient strategy, how we find those decimal remainders to the hundredths place. I have 3 ones right now. I have 3 ones right now, but I need to find a quotient to the hundredths place. So I need to add 1, 2 place values. There's nothing there, so I add zeros. Not dividing 9 into 3. If I am dividing 9 into 3 with no tenths and no hundredths, I'm going to write my decimal place so I don't mess up. Can 9 go into 3? Absolutely not, but it can go into 30 starting in the tenths place. 9 can go into 30 tenths. 30 tenths. So 9 times what number? It's going to give me 30 or close to it. Let's take a look at this taper right here. That taper that goes to 10. 9 times 0 is going to give me 0. 9 times 5 is going to give me 45. 9 times 10 is going to give me 90. Where would 30 fall? Would 30 fall between 0 and 45 or 45 and 90? It would fall between 0 and 45. We can work backwards. So if I had 4 groups of 9, that would be like subtracting 9 from 45. That would be 36. Still too much. We're looking for 30. Another group of 9 less than 36. Another group less than 4 would be 3. I can take 9 away to get 27. 9 can't go into 30, but I can go in 3 times to get 27. That is, I just wrote 22. 27. Awful close. 3. I got 3 in my tenths. 9 times 3 is going to give me 27. I subtract. 27 minus 30. 7 you cannot take away from 0. I need to steal. You need to steal ones and make 10 tenths. 7 tenths minus 10 tenths is going to give me 3 tenths. I subtract those 2's, I get nothing. I'm now working with 30 hundredths. Well, I just did it before. I chunked it out. Okay. I know that 9 can go into 30 unevenly, but it can get us there by 3 groups of 9, which is 27. I don't need to keep going though, because I have my 2 place values to the hundredths. I have 3 tenths, 3 hundredths. That makes 33 hundredths. We have our decimal remainder to the hundredths. Our last step, we need to add the partial quotients and our decimal remainder. What is 500, plus 10 going to give me, guys? I'm just adding 10 to 500. That gave me 510. I then add my decimal remainder. I add my decimals, 33 hundredths. That would be 510 and 33 hundredths. That is our final quotient. 4,593 divided by 9 is 510 and 33 hundredths. On the place value chart, I have 5 hundredths, 1 tens, no ones, 0 ones, 3 tenths, 3 hundredths. That makes 510 and 33 hundredths. All right, guys, our last I do for this entire mini unit. It's going to be a little bit bigger. It's going to be 10 questions long. Break it into 2 sessions if you need to. I want to see all this work with all this learning that we've done for all our learning targets. Super exciting. Show me what you got. Yearn to learn, guys. That's the end of our division unit.